So the topic of today's lecture is Introduction to Classification, and we will talk about mostly simple binary classification. We will introduce the terminology first, and then we'll apply it to classification of Jeopardy questions. Okay, we're going to see what the problem is in a few slides, and this is also going to be the topic of your homework. So let's continue. So classification means assigning a category. Okay, so a category, przepraszam. To będziemy kontynuować. So classification means assigning a category, and in the example here we have two classes or categories. One is dark circles, the other is white circles. We can see that the classification is not perfect. That is, some of the dark circles are misclassified and some of the white circles are misclassified. We use two features or attributes, that is height and width, and we separate the two classes using a straight line. In general, this separation can be a hyperplane in a multidimensional space. So one example of doing a similar type of classification is spam filtering. You can find an article about it in Wikipedia, but in this case, we use multiple features, so the separation will be in some high-dimensional space. The features are words. The features are IP addresses from which the spam or the mail is sent. The idea is to find the best classifiers such that we do not get the email we don't want and we get the email that we want. Yet another example of classification would be use classification or some other data classification. Very often we want multiple categories. So for example, we want to classify use into sports, politics, money, and we perform this classification by using multiple binary classifiers. So for example, we say that the article is about money or is not about money. An article is about politics or is not about politics. This allows us not only to put the news or other pieces of data into these buckets or classes, but also some of the pieces might be about multiple topics. So for example, a piece of news might be both about politics and about money. The third example is fraud detection. So in this case, we want to understand whether a transaction is legitimate or not. And the features or attributes might include the amount on the transaction, the vendor of the transaction, the geographic area, and possibly some other features like the patterns, whether this is the type of product that the credit card holder usually buys. So here we have an example of a rule-based classification. So in this case, we design a collection of rules that allows us to classify, in this case, a transaction into two classes, X and Y. X is approve a transaction and Y don't approve or make it checked by human. So in the box A, the first is the number of transactions with this mentioned using this credit card. So if the number of transactions is smaller than 2, and then we go to the next box. Okay, so in this case, B less than 2 is the current transaction amount. So if the current transaction amount is smaller than, say, the median transaction amount, which can be, say, $200, then we approve the transaction. Then there could be some other patterns in fraudulent transactions. So we can ask the question, okay, is the transaction smaller than $400? And if it's true, then we do not approve transaction, but if it's false, that is, it's a larger transaction and unique, we do approve this transaction. And this can be based on some statistical data saying that, a lot of fraudulent transactions are between $200 and $400. So we see that in this case, we have a collection of rules which allow us to use features and classify a transaction into approved and not approved. There is a classical example in WECA. Okay, we talked about WECA in the class in Warsaw. So here we have different classes of features or attributes. So the attribute can be temperature, the attribute can be numeric, the attribute can be true or false, or yes or no. So the problem here is, depending on the weather, to decide whether to play or not play. As we can see, we have two classes, yes and no. It's here in some peaks, so let's check what it is. Czy ja mam się zalogować ponownie? Nie, dobrze. Będziemy kontynuować. Także, so we see two classes. The classes are simply yes or no. We go and outside and play, or we do not play. The format of data in WECA is that we specify the relation, and in this case the relation is weather. We specify a collection of attributes that we mentioned before, that is outlook, temperature, humidity, windy, play. And under the attributes we specify the data. So we specify what we know about this problem. So in this case we have about a dozen data points, but in the homework I will ask you to create a classifier based on about 1,000 data points. So in this case we apply a logistic regression classifier to the previous problem, and we can see that we have classified correctly as play 6 examples, and correctly as not play 2 examples, and 3 examples are classified incorrectly as yes, and 3 examples are classified incorrectly as no. This is seen below in the confusion matrix. We're going to go over it in the next slide. You can use different classifiers, and WECA provides a choice of about 24 or more classifiers, and there is in general no accepted methods of choosing the best performing classifiers. People simply experiment with different ways of classification. So this shows a fragment of the previous slide. So on the left, we see these misclassified attributes. So we have yes classified. So what we want is these 2 values on the diagonal going from left to right, so with the positive slope. We want these 2 values to be as small as possible, which means that the diagonal, which has 4 and 3 in this example, we want these values to be as big as possible. Another measure that we often use is the F measure, which is shown on the right. and we want the F measure to be as big as possible. This measure cannot be bigger than 1, but we would like it to be as large as possible. In some problems that are quite difficult, we do not get high F measure. The F measure about 85 is often considered good, although it wouldn't be good, for example, for span filtering. More about classification in WCA. I mean, there's plenty of information on the internet. If you have a particular problem, the easiest way is to use one of the tutorials on the internet. You can find them either by looking at the link or just looking at the pictures. So if you want information about the visualization or about putting together a WCA project, you can just look at some of these pictures, click on the link, and find additional information. So now let's look at the classification problem in the Jeopardy domain. So first we can observe, and you have access to the 53,000 Jeopardy questions, so we can observe that most of the questions in Jeopardy can be answered without knowing the question category. So for example, we have this question in the category American Mountains, and it says 1931 completion of the Bucknell Dam created a beautiful lake in this Missouri mountains, and the answer is the Ozark. And this can be answered without knowing the category, because the lexical answer type, these Missouri mountains, is a subtype of American mountains. So it's so the information in the category in this case is redundant. Similarly, in the second example, visiting the New York Transit exhibit in Brooklyn, you can pay the admission fee with one of these. And the idea is to associate the admission fee with the transit, with the subway, and the answer is a subway token. And the fact that the category is travel and tourism is not very relevant here. So let's continue to the next slide. And sometimes category can be misleading. So for example, here we have British Poets Laureate, which might suggest that the answer is a poet or a British poet. And the question asks essentially for a fragment of a quote. So we have the question reading that John Masefield got the job with lines like, "All I ask is one of these, and a star to steer her by." And the answer is a tall ship, which is definitely not a British poet laureate. On the other hand, short clues often require category information. So here we have the question, which is simply Persia, and, well, it can be anything, yes? I mean, we do not know what this question is about until we find out the category information. So the category information is new name, and obviously we can then answer this question as the new name for Persia being Iran. So the problem that we can ask is how short, okay? So how many characters should the question be that would require a category information? Obviously, very short questions require the category information. A very long question usually do not. What is the optimal size of the question where we would like to include the category information when doing a search or doing lexical answer type detection? So here we have an example where the category information is needed for the lexical answer type detection. So the question is, the Stanley Cup And obviously it can be associated with a lot of things. But, and similarly for search, we have the question Parsifal sought it. And in this case, we don't know what it is. Bing search does not give us the information until we find the information about the category. So let's look at the categories here. So the answer for the first question is hockey, and obviously what the question asks is a sport. Okay, so the sport cups, the cup is redundant, so something related to sport is the lexical answer type. In the second question, the answer is the Holy Grail, and the category helps us finding the answer. It has the word holy not only there, but it's also emphasized with the quotation. So the group homework is to build a classifier that finds the optimal number of characters in the clue, so that including the category information is necessary to find an answer. This is due January 5th, and what I would like you to do is to create train and test set of about 1,000 plus questions. So this is a group homework. So we need 1,000 plus questions for training set and 1,000 or more questions for test set, which I think it would come to about 26 questions in each category for training and testing per person. To make the classification simpler, okay, it would be best to have a balance of 500 yes and 500 no examples. There's 500 questions where the information about category is necessary, and about 500 questions where the information about category is not necessary. So after that, each person should try 3 randomly selected WCAG classifiers of this 1,000 plus question sets and report the results. So, for example, we can see it in the next slide. Oops. Sorry, that's going to be one of the later slides. So how to know if the category is necessary? First, you guess, then you run a Bing search on the clue, first without the category, and then with the category, and you will get, if without, the answer doesn't appear in the first page of the results, then you need the category information. If the answer appears in the first page of the results, you do not need the category information. If Bing search doesn't produce the information in either case, then you simply discard the question. So here are some examples. So the previous example of Holy Night, we obviously need the category information here because we need it for Bing. Similarly, we need the category information for the short question Pueblo with the answer Colorado. On the right-hand side, we see 2 examples of questions where the category information is not needed. So most Cornish people live here, does have an answer in Bing. Cornwall, that is, Cornwall appears in the first page of answers and short abstracts. And the natural color of chlorine gas also can be detected without knowing that this is about chemistry. So here we have a similar data set, okay, so we're going to have a simple one attribute classifier, okay, so we have 2 classes, yes and no, and 1 attribute that we use for classification, a numeric attribute called humidity. And the relation is whether humidity implies rain, so we want to find the association between the humidity and rain. So it's very similar to the association between category needed and the length. So here is a couple of data points. So we have when the humidity is 10, there is no rain. When the humidity is 11, there is no rain. When the humidity is 20, there is no rain. When the humidity is 100, there is rain. And then there are some cases in between. So, for example, 75, 76 is no, 70 and 80 is yes, and 40 is also yes. This is a comment, okay, so we can put comments in our data set for WCA. Sometimes it's useful to do it in some encodings. The @ sign is not recognized properly by WCA, so it's best to include the % sign and include a comment in the to convert your data set in some similar data set, but you will have, instead of having this 8 or 9 points, you will have two sets of 100 or over 100 data points each in your collection of data, so it's going to be a longer file. So here is an example of using an ordinal classifier, which seems to work reasonably well, on the problem of the humidity, flying rain. As you can see, I tried several classifiers. Some of them work equally well. Some of them are worse than this ordinal classifier. So let's look at the details. What we see here is that if the humidity, it's a very simple rule, if the humidity less than 20, then there is no rain. If the humidity is greater than 20, then there is a rain. So the no case is classifies correctly 3 instances. The yes case classifies correctly 6 instances and misclassifies 2 instances. So we can see, classifies altogether 6 instances, of which 2 are misclassified. So we can see it in the confusion matrix at the bottom of the slide. Okay, so in this case, 2 cases of yes are classified as no. For an extra credit, you can add other features and try improving the classification accuracy of these problems. So you can use, for example, presence of certain words as features, or the size of the category, and see if this improves your classification accuracy. If there are questions, you can ask them now, or for those of you who are not online at the moment, you can send your questions to the email address at the bottom or in the middle of the slide, and I will answer these questions in the next presentation. So I think we're going to unmute the microphones now, and if there are questions, I will be happy to answer them.